Okay, 11 is the last question on the forces. It says 10 kilogram box is dragged across a horizontal surface by a 100 Newton force that is applied at an angle of 30 degrees above, here we go, above the horizontal. The coefficient of friction is zero point 0.2. Determine the acceleration of the box. Okay, so I did the niceness of drawing a force diagram for you guys so you can visualize this. So we know that force gravity and force normal are going to balance out. And so I broke up force pull into two different vectors, the x right here and then the y. And it says it's being pulled by the 100 Newton right there, just like that. So it's like that, and an angle of 30 degrees. So when we write the equations out like we did in the previous problems, we're going to have force normal plus force pull y plus force gravity will be equal to 0 because this positive plus this negative will all balance out to 0. So what we're left with is force pull x and force friction. So we need to figure out each one of those. So the equation for force friction is force normal. Where is it? Force normal times the coefficient of friction equals force friction. So I'm going to first figure out the x because we said that the force pull x plus force friction will equal the force net. So our little equation right here. And we need that equation in order to find the acceleration because force net times is equal to mass times acceleration. So I'm going to solve for this right here, that right there. So how you're going to do that is taking the cosine of 30 degrees. So cosine, because it's cosine is opposite, or no, I mean is adjacent over hypotenuse. So this little, x right here is equal over 100 newtons will be equal to what we need to find. So cosine of 30 over adjacent, or is equal to adjacent over hypotenuse. So how you would actually do that is force pull x is equal to the cosine of x over 100 newtons. I know I said that really crappily, but that's just me. So cosine, well, you'll get a number, times it by 100 solving for x. If you don't know how to do that, watch all the other vector problems. And you'll get an x of 86.6 newtons. So that is our first part of here. So that's right there. That is 86.6. So we need to find friction now. And I showed you the equation before. Force normal times the coefficient of friction is equal to force. Or force normal times coefficient of friction equals friction. So we need to find out how to do that. We know that the other equation is force normal plus force pull y plus force gravity is equal to 0. So we need to figure out what force normal is. But we doesn't tell us anything about force normal, so we need to solve for force normal by finding out what the force pull y is. Because if you know that, because the guy's mass is 100, or the guy's force he's applying is 10 kilograms or 100 newtons. If we can find, we know that would be negative because it's gravity. If we can find out what the other one is, or if we can find out what force pull y is, then we can just add that to 100 newtons or negative 100 newtons to find out the result. So we're going to look back up here, and we're going to solve for this one right here. So we're going to do that by taking the sine of 30, which is equal to the y, force pull y, over 100 newtons. So I'll show you that. That, by the way, does not say force pulley. It says force pull y is equal to sine of 30, which is equal to y over 100. When you solve that, you'll get a number, and then you'll times it by 100, which will get you 50 newtons. So it's pretty. That wasn't that hard of a equation or a number to do. So when you go back up here, you put 50 in. So you do 50 minus, or 50, yeah, 50 minus 100, so you'll get 50 is what you need to add to it. So 50 plus 50 equals 100. So that's what your force normal will be. So when you know that, then we can go down here, plug that into our formula to find friction. So 50, positive 50 times 0.2 is equal to negative 10. You guys are like, what? It should be 10, right? Well, I read the problem like this. If friction is going the opposite direction of what it's pulling, so if this is going this way, right, friction is going to be going that way. So it needs to be a negative number. So that's why I made it into negative 10. I don't really know exactly where, because the force normal will be going up, so it should be positive. So maybe the coefficient of friction should be negative, but the force friction should be a negative number because it's going the opposite direction. So then we have what we can do for our net force. We have pretty much everything. So we do our equation of negative, or we add those two together. Negative 10 newtons plus 86.6 newtons, which we found for the X force pull X. So now this is our total net force, which is 76.6 newtons. That's our net force. So then we can plug that in to the typical equation, which is, force net equals mass times acceleration. They give us the mass, which is 10 kilograms. So divide 76.6 newtons divided by 10 kilograms, and you'll get 7.66 meters per second squared as his velocity.